In this video, so hi there. In this video, we're going to discuss dependent samples t-test, and these were the tests that we have discussed already. We have discussed the independent samples t-test, and today we're going to discuss the t-test for dependent samples, or also known as paired t-test. So previously in the t-test that we have learned before, it's called independent because we are saying that the samples or the groups where the samples came from are independent. Here, a different version of the t-test will be explained wherein the samples or the group of samples are dependent. That is, we're saying it that they are paired. One very much example of this is when they are matched, like in a pre-test and post-test manner. So you can imagine in a pre-test post-test manner wherein you have the same group or same set of samples or participants, and you're going to test them twice. Usually we test them twice because there is an intervention in between the two testing. So for example, you have a pre-test first and you input your program or your intervention, and you want to measure if the intervention is effective. Hence, a post test will be applied, and a difference of the scores will be checked to say if ever your intervention is effective. So, suppose a psychologist wants to see whether a mental therapy will affect the reaction time. To test this hypothesis, you must first have a pretest to ascertain their normal reaction times, and then we're gonna go through the mental therapy, and then we're gonna use the post-test to determine if there's a significant difference between the pretest and post-test, and hence saying that it is effective. Your mental therapy is effective. So this goes with a lot of other things, not only with psychology, but in a lot of other things, of course. So since the participants are used in both cases, or rather the same participants, the samples are so-called related. So the t-test for dependent samples, we cannot use independent samples here. A special t-test is used called the paired t-test. This test employs the difference in values of the matched pairs. So the hypotheses are as follows. The null hypothesis will be that the difference or the mean of the difference is equal to 0. That's your status quo. And the alternative hypothesis will be the mean of the differences is not equal to 0, or it's going to be two-tailed. You can actually use a left tail test, which wherein you want to make sure that, or you look forward that the scores in the post test will be lower, so you use this tail. And if you're looking forward that the scores should be higher, you're going to use this tail here. So note that the mu of d is equal to the mean sub 1 minus mean sub 2. That is the difference of the two measures, wherein we have the pre-test minus the post-test, or vice versa. So note that this is our just some notes, especially if you're using the software Jamovi. It might a bit be confusing. So this slide will be for you. We're gonna make use of Jamovi. Right now, I'm gonna show you how to use JASP. I have a separate video for Jamovi, by the way. Um, to make things simple, the t-test for dependent samples has only one um, strict assumption or normality because it's a parametric test. So recall that we need to use the Shapiro-Wilk test to determine if it's normal or not. Again, normality can be tolerated if your sample size is enough. So for this case, dependent samples t-test, the enough sample size would have been 35 or up. Okay, to be safe, 35 and up. So we're gonna make use of the p-value approach just to determine if there's a significant difference or not. And this is our decision rule as follows. We also use this in the previous slides. So let me say or read this. State the null and alternative hypotheses and select the alpha level. That's the one. Two is, you apply the tool, you do the statistics in statistical software and compute the p-value. Number three is decision rule. Apply the p-value and determine if it's less than or equal to your alpha. Then we reject the null hypothesis. If it's greater than your alpha, therefore we do not, or we fail to reject the null hypothesis unless we make the conclusion, of course. So this is the flow chart that I made, especially if you're using a software. Uh, Particularly in this software, I use Jamovi. And hopefully this will help. If there's no question regarding the normality, we're gonna make use of students' t-test in that matter. But if there is a a violation in the assumption of normality, we're gonna make use of Wilcoxon rank test. Okay, and the same follows.